For centuries, humanity has observed the universe through the lens of light, gazing at stars, galaxies, and nebulae across vast cosmic distances. Yet, what if everything we thought we knew about the cosmos was merely one part of a much grander, more dynamic symphony? What if the very fabric of reality itself was not static and unwavering, but a dynamic, undulating medium constantly responding to the universe's most violent events? This is not science fiction. This is the astonishing reality of gravitational waves, an unseen phenomenon that is literally stretching and squeezing space-time around us at this very moment. You are about to embark on a mind-bending journey with SpaceRepo to understand these cosmic ripples, why they are so incredibly difficult to detect, and how their discovery has utterly revolutionized our perception of the cosmos. Prepare to have your understanding of space, time, and the universe fundamentally transformed. At its core, gravity is not merely a force that pulls objects together. It is a manifestation of mass and energy, warping the very geometry of space-time. Imagine space-time as an immense, flexible trampoline. When a bowling ball sits on it, it creates a dip, and marbles roll towards it. That is gravity. Now, imagine two massive bowling balls, say, to black holes, spiraling into one another and ultimately colliding with inconceivable energy. This cataclysmic event would not just warp space-time. It would send ripples, like waves on a pond, propagating outwards at the speed of light. These are gravitational waves. Albert Einstein first predicted these elusive ripples over 100 years ago, a direct consequence of his groundbreaking theory of general relativity. He understood that accelerated masses should produce these waves. Much like accelerating electric charges produce electromagnetic waves, such as light. However, Einstein himself believed these waves would be far too faint for humanity to ever detect. Their effects are incredibly subtle. Even the most powerful cosmic collisions only cause incredibly tiny distortions in space-time by the time their waves reach Earth. To put this into perspective, the gravitational waves detected from merging black holes distort distances by less than the width of a single proton over several kilometers. Detecting something so infinitesimal required an instrument of unprecedented sensitivity and ingenuity. That instrument is the Laser Interferometer Gravitational Wave Observatory, or LIGO. Is not a telescope in the traditional sense. It does not collect light. Instead, it is a detector designed to measure incredibly small changes in distance, looking for the tiny stretches and squeezes caused by passing gravitational waves. It consists of two massive observatories, one in Livingston, Louisiana, and another in Hanford, Washington, separated by more than 3,000 kilometers. Each observatory has two arms, several kilometers long, arranged in an L shape. Inside these arms, laser beams are bounced back and forth, precisely calibrated to measure any minute change in the arm's length. When a gravitational wave passes through Earth, it momentarily stretches space-time in one direction and compresses it in another, then reverses the effect. This causes the arms of LIGO to microscopically change length, ever so slightly, creating a detectable interference pattern in the laser light. On September 14, 2015, LIGO made history. For the very first time, humanity directly detected gravitational waves. The signal was a distinct chirp, indicating the final moments of two black holes, roughly 36 and 29 times the mass of our Sun, spiraling into each other and merging into a single, more massive black hole. This momentous event occurred over 1 billion light-years away. The energy released in that collision was staggering, equivalent to converting 3 solar masses directly into gravitational wave energy in a fraction of a second. Think about that. 3 suns worth of mass instantly transformed into pure space-time ripples. This discovery was not just a confirmation of Einstein's incredible foresight. It opened an entirely new window onto the universe. Before LIGO, our cosmic observations were almost exclusively limited to electromagnetic radiation. visible light, radio waves, X-rays, and gamma rays. These all travel through spacetime. Gravitational waves, however, are spacetime, allowing us to probe parts of the universe that are utterly opaque to light. For example, the earliest moments of the Big Bang, or the hearts of collapsing stars where light cannot escape. Since that first detection, LIGO and its international partners, Zvirgo in Italy and Kagra in Japan, have detected dozens more gravitational wave events. These include not only binary black hole mergers, but also the collisions of neutron stars. These neutron star mergers are particularly exciting because they are thought to be the cosmic factories for heavy elements, like gold and platinum, showering the universe with the building blocks of planets and, ultimately, life itself. Imagine listening to the universe's most extreme events, not seeing them, but feeling them. Gravitational wave astronomy is still in its infancy, yet its potential is immense. It promises to reveal an entirely new population of cosmic objects we cannot detect with light, such as intermediate mass black holes or even more exotic phenomena that are currently only theoretical. It offers us a direct probe of the Big Bang, potentially revealing secrets about the universe's very first moments that are forever hidden from electromagnetic observation. The universe is far more dynamic, more violent, and more inspiring than we ever imagined. Gravitational waves are the universe's secret language, a symphony of its most powerful forces, and we are just beginning to learn how to listen. The future of astronomy is not just about seeing the stars. It is about feeling the universe breathe. What cosmic event do you believe would generate the most powerful gravitational waves, and why? Let us know your most mind-bending theories in the comments section below. And do not forget to subscribe to SpaceRepo for more journeys to the frontiers of human knowledge. Your curiosity fuels our mission.